So this is my sixth redo on this one because my phone has died and then my phone has ran out of space. So here we go again. So the strongest reducing agent is the thing that does oxidation the best, or it causes something to be reduced the best. So that would be D because it has the most negative reduction potential. So it has the most tendency to give up its electrons, to lose basically. So it's the best reducing agent because it gives its electrons away. So it's going to be a negative 1.38 and D. The strongest oxidation agent is just the opposite of that. It has the most positive E value, and it's the best at stealing electrons, so it's the best oxidizing agent, causing something to be oxidized because of it. And A has a E reduction potential of 1.47, which is a big positive E value, so we can tell that it's the strongest oxidizing agent. So this is a problem where we're doing spontaneous oxidation by B. Now the reasoning behind this is that B is causing oxidation to happen. So that means that it is reducing the thing that it's working with. So basically anything that's smaller than this 0.6, which is B's cell potential, is going to be it's going to be oxidized by B because it has a smaller cell potential than B. And B will oxidize it and B will be reduced, but B is going to be the oxidizing agent and this is going to be the reducing agent. So it's just language flipping all over the place. So the way you can tell it's spontaneous is if it's an E value that's positive and greater than 0. And in both cases it is, so C and D are spontaneously oxidized by B. Okay, so now it's basically the reverse of this, saying what can be spontaneously reduced by C. So what is the best at giving up? So in what situation would C give up its electrons? So C has a negative potential. So anything that's bigger than C is a situation where it would move towards the oxidizing agent, or the thing that's doing the the thing that's doing the oxidation. And so it would be reduced by C. So anything that's bigger than 0.21 is going to be reduced by C. It's going to cause a gain for both of these. So A and B can both be spontaneously reduced by C because these values are bigger than 0 and they're positive, so A and B can be spontaneously reduced by C. So basically, just to cap that off, just to make this more clear, and also partial for my own education, the reduction and the oxidation, reduced or oxidized by something. So reduced by C means it's giving its electrons to whatever the subspecies, whatever the cathode is. And then oxidized by B, meaning that it's taking away the electrons, or it becomes the cathode. Anyway, so this is the balanced half reaction these are the half reactions for A and D, and then these are rewritten here because they weren't written in the right format first. So A3 plus 2E is equal to A plus, D goes to D plus, and then E. So multiply these by 2, so these E's cancel out, that's right here. And then A3 plus 2D goes to A plus and plus 2D plus. So basically you can tell this is balanced because there's 2 electrons being transferred to A, and so it's being reduced, and D is being oxidized and has 2 electrons being taken away because you have 2 D pluses. So it was a D1 plus and a D2 plus, which were D's before and donated their electrons to this A. To calculate the cell potential, take the E cell for the reduction potential minus the E cell for the negative E cell for the reduction potential, or the oxidation potential, as I've written here, which I did 1.47 minus 1.38, which is 2.85 volts. That is chapter 17. Hope you have a great day.